Hi everybody, so this is the video for section E, which is the multiplicative identity and inverse matrices. So the first thing we want to talk about is the multiplicative identity, and I know that's a big word and it seems a little intimidating, but I want you just to remember it is the equivalent of thinking about the number 1. Okay, so with the number 1, we can multiply anything we want by the number 1 and it doesn't change it. Right? You end up with the answer that you started with. So if you take like 6 and multiply it by 1, we get 6. If you take -6 and multiply it by 1, we get -6. If you take any decimal, any fraction, any real number and multiply it by 1, we get the same number we started with. So that's known as the multiplicative identity. So what we're looking for with matrices is a matrix that we can multiply by any matrix and get what you started with. Okay, so with a 2 by 2 matrix, this is the equivalent of 1. This is the matrix that you can multiply by any 2 by 2 matrix and get the matrix that you started with. Okay, so you can multiply any matrix A by this, what's known as the identity matrix. Multiply any matrix by the identity matrix. Order doesn't matter, and you're going to get the matrix that you started with. Okay, so if that's the case, then think about when we have a number and we multiply that number by its reciprocal, right? Reciprocal being to the power of -1, 1 over that number. So if you had like 2 and you multiply that by the reciprocal, which is 1/2, you end up getting 1. So if we multiply any number by its reciprocal, we end up getting 1. When it comes to matrices, you want to be able to multiply a matrix by its, we don't call it reciprocal, we call it the inverse, and we want to get the identity matrix. So that's what an inverse matrix is. It's the matrix that you multiply the original matrix by to get this identity matrix. So it's kind of like the equivalent of thinking about reciprocals and the number 1 in thinking about inverse and the identity matrix. So that's sort of where we're headed. So this is the next piece of the puzzle that we're going to need in order to solve simultaneous equations, is this idea of the inverse of a matrix. So what is the inverse of a matrix? How do we find the inverse of a matrix? So if you have a matrix A, B, C, D, and the determinant of that matrix, we learned in the last video, AD minus BC, as long as that doesn't equal 0, then to find the inverse of a matrix, we're going to do 1 over the determinant, and then we're going to multiply that fraction by this slightly rearranged assortment of the elements from the original matrix. So you'll notice that A and D have switched places. So D is now up here and A is down there. So whatever the numbers were in your original matrix, those two positions change places. Then with the other two, B and C, those become negatives. Or if they were negative, they become positive. They become the opposite sign of what they were. Now, note that this happens after you take the determinant of the original matrix. So when you take the determinant, it is of the original matrix in its original form. Then, to find the inverse of your matrix, then you do this rearrangement and the 1 over the determinant. Okay, so let's work this through with some actual numbers and see how this all kind of pieces itself together. So if we have matrix A, 2, 5, -3, 1, we want to find the inverse. So we have to start by finding the determinant. So first thing, I'm going to find the determinant, and that's going to be equal to A times D, which is going to give me 2, minus B times C, which gives me -15. So my determinant is equal to 17. Okay, so then we go ahead and we find the inverse. So we've got 1 over, and I just figured out the determinant to be 17, and then we're going to multiply that now by this slightly rearranged assortment of elements. So A and D switch places. So now the 1 goes up there and the 2 goes down there. and B and C switch their symbols. So that becomes a -5 and that becomes a +3. Now what we have is we have this scalar quantity multiplying onto your matrix. So if you remember back to section B, we talked about if you have a number multiplying into your matrix, you just multiply each of the elements by this number. In this case, it's an unfortunate fraction. So our inverse is going to be 1/17, because that's 1 times 1/17. -5/17. 3/17. And 2/17. These inverse matrices almost always end up being unfortunate fraction answers, which is okay. So that's how you find the inverse of a matrix. So we're sticking with 2 by 2 matrices. So again, your calculator could do higher order, but by hand, 2 by 2 is as far as we're going. So let's look at another example. We have matrix B, which is 1, -2, -2, 4. We want to find the inverse of that. So again, we're starting with the determinant. That's the first piece we need to find. And we've got AD, which is 4 minus -2 times -2, 4. So my determinant is 0. That needs to kind of set off alarm bells, because if you remember back up when we talked about what the inverse was, we said as long as this determinant does not equal 0, then this is what you do. Because that determinant equals 0, when we try to put the 0 as the denominator of our fraction, we get something that doesn't exist. So we can jump right to b to the -1, the inverse of matrix B does not exist, because we can't put 0 in the denominator of a fraction. So the inverse of B does not exist. Okay, let's talk about how to find this on a calculator. So let's just do the example that we just did with A on the calculator. So again, everything starts in that matrix menu. We're going to go over to edit because we want to put in a new matrix. I want to edit number 1. It is a 2 by 2. So then I put in 2 and 5, -3 and 1. Okay, so I've got my matrix in there. So I'm going to get completely out of that by doing second mode to get that quit option. So get back to a main screen. And then what I want to do is I want to recall that matrix A. So go back into my matrix menu, and now I want to use this list of names. I want matrix A, and then I've got this x to the power of -1. That's what I want to use. And then I hit enter, and here's the problem with doing them on your calculator, is you get a whole pile of decimals, which we don't really want. We don't want our answer in decimal form, we want it in fraction form. So if you'll recall, there is a quick and easy way to change decimals to fractions with your calculator. You're going to go into this math menu, hit math, and option number 1 says frac, so I can just hit enter, and this comes back on my screen, and I hit enter, and it changes all of those previous decimals into fractions, and hopefully, fingers crossed, we got the same answer as we did by hand. So again, if this is in a calculator section, you can absolutely use your calculator and do it that way. If it's in a non-calculator section, you're going to have to know how to do this process by hand. Okay, and that about does it for section E.